Okay, so you guys can follow along in more written detail in the supplementary materials. But right now we're going to talk about the factors that affected the bridge design. And so the first was the engineer in charge, E. Lionel Pablo and his team. And they were known for their steel truss cantilever design, which they implemented across the country in Mississippi for the Vicksburg Bridge and for the Silver Memorial Bridge in Ohio. Moving on to the economic factors, this area around the Delaware River relied heavily on the transportation of goods through cargo ships. And this required the Commodore Barry Bridge to have a certain clearance, and that was about 192 feet. Design-wise, this bridge had to be built across the Delaware River, which is in that area that they built it, it was pretty wide. And so this required the bridge to have a minimum length well over 1,500 feet, and especially this truss structure. And for this type of bridge, that's a certain length, a steel truss cantilever design is best suited for that. And they also decided to use a Warren truss for the Commodore Barry Bridge. And these trusses are very light in weight, and the horizontal members support most of the load, while the vertical members do the stabilizing. They stabilize those horizontal members. And so looking at it, a lot of these factors intertwine. Because of the length of the bridge, it made sense that a steel cantilever truss was used. This also made sense for a Warren truss to be used since it was it's a lot lighter. And it also made sense that they used E. Lionel Pablo and his team because they're known best for this type of design, which was used for a lot of the longer bridges in this time period.